So let's take a look at the results that we have so far. So here's the survey that you looked at. It asks what your name is, a couple of questions around your name. It asks where you were born, and I'll explain why later, but I provided specific examples on how to fill that out. Where do you currently live, if that's different from where you were born? So both of these, up to this point, are questions that you answer by filling in text. And then we have some check boxes. So what pets do you have or would you like to have? And you can check one or more of these, including an other. So you can check that and fill in some text to say that I have, or I want this other type of pet that I haven't listed so far. This one is different. It's not a multi-select, it's a single select. So you can select what type of car you drive or no car. Back to multi-checkbox for your hobbies. But again, just like with the pets, we had one where we can fill out any additional hobbies that we may want to add there. Same with the visualization tools that you've used. And the very last question is, how well do you know Keylines? So Keylines is the graph visualization library that our company makes, and I'm using that to create the visualization that we'll be taking a look at today. There's no dependency specifically on Keylines. In fact, if I were building this again, I might choose regraph because it is very state-driven. We're looking at the data that is being generated from this survey, and we're generating a visualization from that. But I chose to use Keylines because it's very event-driven, and I want to create events that say, do this, run this layout, add this new data, create these groupings, and so on. So I've chosen to use Keylines, but I could have just as easily done a more state-driven model. So the first thing that we need to do when we look at a graph visualization project is what sort of use case, what are we doing? What do we hope that our users will learn from this graph visualization? And because this is sort of biographical data, then we need to determine what is that, who's going to find that useful, and what are they going to do with it? It's a little bit of a contrived example here in this webinar, but the idea is that we want to learn what we all have in common. You know, we're all attendees on this webinar. We're attending from all over the world. We've been born in different places. We have different pets and so on. So what do we have in common with one another? What might generate interactions outside of this webinar? If you see somebody else who's from the same area that you are, who has the same pets and so on, you might want to reach out to them. So it's a very kind of social network type of graph that we're looking at. And that's going to guide some of our design choices that we make later on in the session. But the next thing that we need to do is we need to decide, how do we take what is being given to us in survey responses and turn that into a graph? So for those of us in the company, we think of graphs every day, and we model everything intuitively as a graph, but it's not a trivial process to take what is ultimately columns and rows and turn that into nodes and links. There are ways of doing so that are useful, and there are ways of doing so that are less useful. So a graph is really valuable when you care about the relationships embedded in the data. So the relationships embedded in this data are from an individual to his or her pets, cars, locations, and so on. So that's going to help us figure out what sorts of things are useful to model as our nodes and our relationships in the underlying source data. So the Google form helpfully has a link directly to a Google Sheet, and that is what creates the data that we're going to read from. So we've created a little driver that will just go in and look at the results that we get on this Google Sheet, but we're just going to take a quick look at the first few results and see how the data is formatted and what we might want to do with it. So it's pretty straightforward. We've got the date timestamp that we filled it out. We have the one that I did just to test and make sure everything was working okay back on Friday. And then we have the results here, starting with the line number 2, which are the ones that you all have filled out as attendees. We have a column for your first name, for your last name, where you were born, where you currently live, and so on. So the first 4 columns are pretty straightforward, except that one of the reasons I asked for your location written out as the full name of the state or the country is because we want to match one to another. So if I link from Corey to Massachusetts, if somebody else had put that in as Lowell, Massachusetts, or MA, for example, then those would be represented as different nodes on the screen, and we wouldn't get those connections. So I can see that most of you sort of obeyed those recommendations, but a few haven't. So we'll see what the results look like when we get to the visualization. But we got to think about what are our node types first. So our node is, or the first node that we want to create is a person. But that's a little bit tricky because we have to think about what are the actual fields that represent a person. And it's not just a one-to-one correspondence. So if I just said our node type is whatever you put in this first column here, that whatever you filled in for your first name, then I would not get useful results because multiple people share first names and they would all be represented as a single node on the screen. So for example, if I had, John Smith and John Williams both fill out the form, then they would both have just a single node which said John. And possibly if we had chosen the last name as a separate node type, then we would have a link from John to one to Smith and one to Williams. That's not what we're really trying to uncover here. It may be useful in certain circumstances. You may want to say people who are named John are more likely to own dogs and people who are named Corey are more likely to own ferrets or something like that. But that's not going to help us solve the social use case that we're trying to uncover here. So what we have to do is we have to create a node type whose identity, and the identity is the unique field which corresponds to that node and no other. And we're going to have to create that from a combination of the first two fields. So even that's not perfect because two people can share both a first name and a last name and yet still be two different people. But it's the best we can do with the data we've collected today. So I'm going to jump over to the source code here where we are creating our model. And our model is just basically a JSON object, which shows how we go through the nodes and links. So if I wanted to create a node that was just that first field, I would say, here's a person and their ID is whatever I found in that first column. But that's not going to give us very good results. So what I'm actually going to do is I'm going to take the ID and create that from a concatenation between what I find in the first column, a space, and in the second column. Now, I could also create a label, a separate label on the node to say, I want to show something other than that person's name. The name defines it, but something else should be shown on the screen when I represent that node. But I'm not going to do that now. In this code, if you don't give it a label, it'll automatically use the node identifier as the label, and that's good enough for here. So that's taking care of our person. But what are we going to link the person to? Well, we have two columns which both represent locations. So we have somebody here who was born in North Carolina, but currently lives in Maryland. Let me make sure I got that. Yeah, I have the order correct. So are those really two separate node types, or are they the same? You could make an argument either way, but what I think, because we're trying to uncover connections that people have, I don't want to have a completely separate set of nodes, which are the locations where people were born, from the set of nodes that are locations where people currently live. And the reason for that is if I was born in Maryland and somebody else currently lives there, we both want to be linked to the same Maryland node. We don't want two separate nodes, which means that me and this other person are completely disconnected from one another. So there's that sort of biographical thing in there too. But the result is that we need to differentiate, because otherwise, if we just show that as being identical, then you won't be able to tell on the graph visualization where people live versus where they were born. So we'll get to that a little bit later. But we're going to create one node type which represents both, which is just a location, both where people were born and where they currently live. Now we get to the next column, which is what pets you have. Now this one's a little bit more difficult because you weren't required to just answer one thing. So I just have a dog, for example, but some people say that they have both dogs and hamsters, or birds and snakes. Some people have an entire zoo. So what we're going to have to do there is create a node type from all the possible answers and then link the person to the various things that they checked off. So that works, except that it's a little bit more difficult because of that other field. If we go back to the survey here, we can see that you could have filled in other and written something in there. So I don't know in advance what all the possible pets you might have had were. So what I'm actually going to have to do is parse through the list of items that were on the chart or in the survey and figure out which ones are split by the comma and then create a value. So I'm basically mapping each value that is on that field into a separate item in terms of the pets. And basically, I'm doing the same thing for the hobbies. So that I'm doing this for the 5th column and doing this for the 7th column. But the same thing, I'm basically just splitting it by that comma. Hopefully, none of you put commas in your others, but we'll find that out when we try to write this and see what it looks like. The single option select for the vehicle is pretty straightforward. If I check motorcycle, I'm not allowed to check other things. So all I have to do is just get the value for whatever is in that field and make that the node type. And hobby is going to be treated the same as pets. You can check off any number of these or fill in another. So we're going to go through the survey, look at all of the things that are comma separated in that column and separate them out into separate nodes and link the person to each one. So we do the same thing for the data visualization tools that you currently use and for which data visualization techniques you like and are familiar with. So now we get to the last one. Let's look at this last one because it's a little bit interesting. I say, how well do you know Keylines? That's the product that Cambridge Intelligence produces that we're going to be using to create this graph visualization. So the options that you can select are 1 through 10. Now, if we go back to the other option box or radio buttons, here we create a node type for each thing you could have clicked and link the person to that. But that doesn't really make sense for this last question. I'm not going to create a node that's titled 1 and a node that's titled 5 and 6 and so on, because that only will link you to the other people who answered that exact same value, which is probably not what we want to uncover here. So instead, what we're going to do here, and we'll look at this in the code as well, is we're going to create a node type, which is just Keylines. It's just a single ID, which is Keylines. It doesn't matter what you filled out there. And the ID is Keylines and the label is Keylines as well. So there's just one node on the screen, independent of how many people filled it out, independent of what sort of box you checked or what value you chose in that list. So that gets us to the list of items, the list of things that we're going to show. And we'll try different visual properties associated with those in a second here. Next, we have to start thinking about the links. So this is a graph. Graphs are comprised of nodes and links, and the nodes have to be connected to one another via links. So we have to create a separate link type for each link that we want to show here. Now, because this is biographical data, what we want to do is we want to take the person who we defined as the concatenation of their first and last name, and we want to link them to a node for each of the other answers that we filled out. So what we have to do is we have to create a link type for each one of those. So here we're going to link the person to their native state or country, and we're going to basically define the 2 endpoints of the links. So the first one is their name, which we've decided is the concatenation between the first field and the second field with a space. The ID2, we're going to say, is just whatever they filled in column 3. Column 3 being what state do you live in, or I'm sorry, what state were you born in? And then the DT here, DT stands for date time. We're going to apply a date time to each link. And that date time, we don't have any particularly useful date time values here, but we do have that first column, which shows at exactly what timestamp you filled out the survey. And for the most part, they're over the course of the last hour or so, with the exception of the first one, which I did earlier on Friday. And the reason I'm actually giving a field for date time, you'll see when we get over to the actual visualization itself. So here we have a link from the person to their native state, the person to their current state. And I say state because the last time I gave this talk, it was mostly United States-based attendees, but it works for country as well. We're going to link a person to their hobby. So this is linking from the person, which we've defined previously, and the ID2 is the number, all the things that they filled out in that field. And what I'm going to do is I'm going to put a label on each link here. So I actually have the text, T stands for text on the label, for whether they have a hobby or have a pet or so on. So hobby and pets we're treating pretty similarly. We're just mapping to each value that they filled out in that field. Same with the graph concepts. Now Keylines is a little bit differently. Everybody gets linked to Keylines if they answered that question at all. Now, how do we want to show that? Well, we want to show that by taking the width of the link. A stronger link means you know Keylines better than if I show a very thin link. So what I'm going to do is I'm going to take W, which stands for the width of the link, and apply that to the value that shows up in column 10. Column 10 being how well do you know Keylines? So some people answered 10, some people answered 5, 6, 7, some people answered 1. So that's pretty convenient because it gives me a 1 to 10 range, and I can just map that directly over to the width of the link. If it were something on a 1 to 10,000 range, or some other numeric value that I wanted to map to the width, it doesn't make sense to have links that are 10,000 pixels wide. They would just obscure the whole screen. So we'd have to do some sort of mapping or some sort of linear or logarithmic correlation between what you filled out and what you want the width to be. But because it's just 1 to 10, it makes it pretty easy. And here, basically, I say if it's nothing, if you didn't answer the question, then I just want to hide the link. Don't show it at all. If you don't know Keylines, you chose to not answer the question, then we won't put a link on the screen because you shouldn't be linked to Keylines. You don't actually know it. So that's what our map currently looks like between the nodes and the links in our graph visualization and the columns and rows that are in the survey results. Let's go and take a look at what it looks like initially. So I have the console open because there are certain things that I'm going to want to do in the console later. We are getting a bunch of errors, and that's because I created node icons for the various things that I suspected you might fill out so that we can see them represented as little node icons as opposed to just circles or squares or something. But, I didn't anticipate that somebody would have the fish. I probably should have, or that somebody was from Bulgaria. So the Keylines is basically just telling me, there's no node icon for Bulgaria that I'm hosting. So we're not seeing one. So that's when, if we look at the results, we're going to see, some little X's here. The X just means I failed to find an icon for Slovakia. So this is what we get initially. We get, most people are linked to Keylines because you filled out the very last question about how well you knew Keylines. We get, some people here. We can click on individual people and see what they're linked to. So this person plays a musical instrument, they enjoy running, they have a dog, and so on. We can see, who has states in common. So I can click Massachusetts and see I've got one other person who was born in Massachusetts where I currently live. Or I can click Maine and see in the 2 years of giving this talk, I've never met anybody else either who lives in Maine or was from Maine. So that trend continues. And we can see what people have pets in common. So if I click, dog, I can look at all of the individuals who filled out the form who have a dog. So on for a cat, all the people who are from the United Kingdom answered that. And now you can kind of see why I asked you to be very specific about how you typed in the results here. We get some people who said, county optional. So that, I don't have a node icon for that, and that's not really that helpful for uncovering, what that person is from. I have 2 separate United Kingdom icons, which I shouldn't have. I suspect there may be a leading or trailing space there. So it correctly found the icon, but it's treating them as 2 different text strings. So I'm doing all of those things because this is just a application that's coded on the fly. I'm not doing a whole lot of error checking or data sanitization or anything like that. But we get just right off the bat some interesting results. But I talked about earlier how it's tough to differentiate here between where somebody was born and where they currently live. So for example, here, I put on the text of the link, Kevin was born in Canada, whereas Paul currently lives in Canada. But it creates these pretty messy links where you have these the text on the label of the link that is not all that helpful, because I can't read which label or which link this label applies to, because it's all over the surface of the chart. So I might want to make some different design decisions here. One of the things I'm going to do is I'm going to go in and I'm going to change this to say, instead of having was born in on the link between the person and the location, I'm going to comment that out. And I'm going to create a color instead. I'm going to do the same thing for where they are from. So links which represent where somebody was born will be red, and links which represent where somebody currently lives will be blue. And we can see the results here. So if I click United Kingdom, everybody who filled out United Kingdom currently lives there. If I click, Maine, you can see that I was born in Maine because of the red link, or I was currently live in Massachusetts because of the blue link, and so on. So that gives us a little bit more of a visually intuitive way of understanding the data that's on our chart, versus having the text and having to inspect each link individually to see whether it's what type of relationship it is, basically. But I'm still stuck with all of these has hobby links. Maybe I don't necessarily need those. Everybody that's linked to a hobby, let's find a hobby. Weightlifting. Everybody that's linked to weightlifting has that as a hobby. Weightlifting is not another option somewhere else in the survey. So the text on the label there isn't really necessary. So I'm going to go through and I'm going to just take that label off. And we just assume if you're linked to a hobby, that's because you have that hobby. And the other thing I'm going to do is I'm going to add a node icon for people. So right now we're just representing people with the generic circle and the label over the text of the circle, but maybe we want to do something fun with that too. So at the same time, I will go through and I'll add a node icon for the actual person themselves. So now we get the smiley face representing each person, and we have obscured or we've taken away the text on the label, which was obscuring what people were linked to and covering up too many labels on the links. The other thing I've done, which is kind of I haven't actually coded, or I haven't shown you the code for, is I've sized the node based on the number of links it has. So of course, Keylines is pretty large because almost everybody's linked to Keylines. But we can see that the United Kingdom node is bigger than the Maine node, because only I'm from Maine. A lot of people who filled this out are from the UK. So that can help make the more well-connected nodes stand out, and they are easier to identify, and you can see what they're doing. And then we'll look at the time bar as well. So the time bar here just covers 3 days, and it's really just me who was earlier when I was testing this out, making sure it still worked. But we're going to zoom in just on May 4th here. So today is May 4th. These times are in GMT. So the talk started at 4 o'clock GMT. If I zoom way in, we can see, the responses start to trickle in. Between 4:05 and 4:10, here are the people that answered. If I scroll a little bit later, I see some things disappear, and I see the people who answered later on in the session, and so on as I go forward. Now, this isn't that useful. I might find interesting things like the people who filled out the form right away were giving true answers, whereas the people who waited a little bit toward the end of the session were more likely to give clever or trying to be funny answers, and so on. But when you do have a time-based component to the actual data you're trying to visualize, the time bar can be really helpful for looking at patterns over time. So I can look at specifically, the people who answered the United Kingdom. There was a rash right at the beginning, and then another set right toward when we handed the talk off to me after Kevin finished his. Whereas if I wanted to look at this individual, I can see that he filled the survey out right at 4 o'clock. This person did so at right around 5 o'clock, and so on. So the time bar can be a little bit helpful there, not particularly on this data set, but certainly when you have a time-based component that is actually relevant to the underlying source data, then it can be. Now, the last thing we're going to do is a real test. So I was only just working with this in the last hour or so. I'm going to do a lot in the console, and I'm not 100% certain it will work. But that's what live coding is all about. So we're going to see. What I'm going to do is I'm going to group together the nodes. So what we are looking at here is a little bit busy. You know, we see there's only maybe 3 dozen, 4 dozen nodes on the screen, but because they're all connected to one another, it creates this kind of what we call a hairball, where everything's connected to everything else. Now, we've tried to help with that by sending to the background the nodes that I haven't clicked on, or what's linked to the ones I've clicked on, and so on. But it still is a lot of stuff clustered around. So what we may want to do is to create groups of nodes and then look at how the groups themselves are connected to one another. And that might simplify the view of the chart a little bit. So I've got this big function here, which will create what we in Keylines call combinations and create those based on a common property. So I'm not going to walk you through each one of those, but what I should be able to do then is combine based on everybody who shares a location of birth. And I have to run a new layout here, so we're going to lay that out. So what we see is now we have all of the people who were born in the United Kingdom grouped together under a single grouping here, what we call a combination. And I can see the individuals inside of there. So here are all the people who are from the United Kingdom. If I select one, I can see specifically what he's linked to, you know, his pets. I left the United Kingdom node icon on the screen. I may not want to do that in a real visualization because they're already grouped by that property. I don't need to also show that they're linked to it. But this might be really helpful in uncovering patterns that I might not see otherwise. So for example, people from the United Kingdom might be more likely to have a dog, whereas people from Canada might be more likely to have a ferret, for example. So the groupings can be really helpful. Now, in this case, it looks like we have a lot of groups of one. We have people, you know, there's only one person from Bulgaria. There's only one person from Maryland, for example. So it's not that helpful in this case to group together. I may choose to group together by other properties, like maybe I want to put all the cat people together and all the snake people together and so on and see what they might have in common. But we have to be a little bit more careful there because everybody only has one country of birth. So I could be reasonably certain that you only answered one thing. In fact, the survey required that you only answer one thing there, whereas you could have multiple pets. But I can't put you in a group that includes both birds and cats, for example. Because of the way the grouping works, you have to be in just a single combination. So you do have to be careful when you do these that you're grouping by something that both makes sense according to the structure of the data and also by a value which is guaranteed to be unique. So that's us building a graph visualization in real time. What we did was we just collected the survey data. We decided what the model was be. We tried a couple of different models to figure out which one might make sense. We decided on the styling and tried a couple of different styles to see which ones helped us out. And then we decided on interactivity. So we did the grouping. We could create a button to create or remove those groups from the screen. So you looked at each icon individually again, and so on. I didn't create any UI elements. I think that'd be beyond the scope of what we're trying to show you today. So I did it in the console. And so basically that pretty much gets me to the end of what we wanted to show today. What we're going to do now is just answer any questions that we see over in the question box on the GoToWebinar. So please do feel free to add more questions as we go. And with that, I just need to take a look at what those questions are. So just give me about 30 seconds to do that, and then we'll start addressing those. And what I'll do is I'll address it to each person who, each presenter individually, and then I'll ask you to unmute yourself and answer from there. So the first one's for Harpreet, and the question is, what have you found the most difficult about switching from writing native JavaScript to writing TypeScript?
That's a good question. I think the most difficult part here is to decide what you want to convert and whether you want to convert your project or not. It's more like a benefits versus efforts decision here. So for instance, if I have a project that is just going to be maintained and I'm not actively developing it, then I would just leave it in JavaScript. But if I know it's actively being developed and there are lots of people writing code for that, then I think it's a good idea to convert that to TypeScript. Another similar thing is that because TypeScript is like I said, it's a superset, so it's a bit flexible on how strict do you want it to be. So although you can set it in the config files and all, but how much strict do you want is another question where you need to decide again on the same basis, benefits versus efforts. And I think apart from this, conversion itself isn't that hard. So let's say if you have decided you want to convert your code to TypeScript, you can just start converting the basic types like I showed in the examples. And if anything is going wrong, your IDE is going to suggest you anyway that there is something wrong. You need to do that. You need to do this. And most of the cases I figured out that if you just copy that error that your IDE is throwing at you and search for that on Google, you will see you are not the only one who is stuck at that point. There are lots of other people who have managed to solve it by just maybe writing something else on top of that. So I think the language itself is okay. It's just the decision what you want to convert is probably the hardest part here.
Okay, thank you, Harpreet. I have 2 questions for Christian. Actually, one of them was just about mustache maintenance, so we'll skip that one. The other one is I'm interested in GraphQL and I'd like to learn it, but one of my senior colleagues made a statement that is GraphQL might not last past HTTP 2 because it's going to have many of the features that GraphQL already has, and it might make it redundant. Do you have an opinion on that, Christian?
It's a nice question. I think this is, as I mentioned earlier, about JavaScript, sort of technologies and how there's a new flavor of the month every month. I would have thought that even if the standard were to replace sort of the core benefits of GraphQL, it's going to take some time for adoption. So you've really just got to try it out on a small project yourself and just see whether it's giving you the benefits that you expect it to, and then once you consider the potential benefits and the downsides, make a judgment call whether to go for it. Like when people ask me if I should be using a graph database versus a traditional relational database, I say, if you're comfortable with the more traditional methods, then why not stick to them? Unless you see a clear benefit, there's no reason to reinvent the wheel all the time.
Okay, thank you, Christian. So for Kevin, we've got a question about can I explore the graph to in-depth in regraph? I guess they're asking about sort of an expand type feature.
Yeah, so you definitely can bring in more data as you go. This is very easy and a pretty fundamental part of the library, I think.
Great. Yeah, so if you do want to take a look at that specific feature in regraph, it is, as Kevin said, a pretty foundational thing that we do in all of our products. Do feel free to take a look at that on our site. A couple of final questions here. So the one for me is, what use cases is Keylines used for? And the answer there is really anything that has to do with graphs. So over the last 7 years or so that I've been working with graphs, the number of use cases where it's been useful has really expanded. So it started off being more security oriented. And I say that sort of vaguely because that could be governmental security, like intelligence or law enforcement, or it could be cybersecurity, where they want to uncover relationships between IP addresses or malware or things like that. But also just in more traditional kind of spaces like retail or in supply chains, looking at the connections between where various components come from and things like that. Also in anti-fraud. So anti-fraud is an area where people use graphs quite heavily because it helps you uncover which types of relationships are ultimately normal business as usual and which ones stand out for some reason that might be worthy of further investigation. So there are a lot of different use cases for graphs. Many of them have a value for graph visualization, but not all of them. And then two more questions, which are not aimed at anybody specifically. One is whether the session will be shared later, and it is. We've recorded it, so you'll be able to see it later, and we'll send around the link afterwards. And the last one is, can I try Keylines? And the answer for both Keylines and Regraph is yes. So if you go to our site, cambridge-intelligence.com, there is a tab that you can click for requesting a trial. And if you do that, it will likely come to one of us, and we can get you set up with a free trial so you can start playing around with it and using it on your own data. So with that, I think we're going to wrap things up. Feel free to reach out to any one of us. I think all of us have put our email addresses in the slides. So if you didn't copy those down, don't worry about it, because you'll see the contact info when we send around the recording as well. And do feel free to reach out to us with any further questions or anything else that's come up. Thank you very much for attending from all around the world, and we look forward to doing more of these in the future.